Hello viewers on YouTube. What's up? Forgive me. There's a video I want to do on the windmill. And this I'm in my house, but I'm taking some survey of the land and of how the atmosphere is. Realize that the way the wind is blowing, it's not blowing at the steep rate. It's blowing with some rate. It gets to some time and it stops. It gets to some time. It's blowing very fast. Yeah. So it's to determine what kind of windmill I'm supposed to do. I don't just start doing any windmill anyhow. Let me read something to you that I've realized about windmills. I don't know what I mean may be correct, but that's what I've realized so far. That the ability to turn the rotor with a certain strength, not speed, gives you high current. But the ability to turn the rotor at a certain speed gives you the voltage you want. The kind of wind turbine you do depends on the nature of air around you. The heavier the wind or the pushing the wind, the more torque you can get. That's why I realized the ones on television, the ones those abroad are doing are quite are quite big and they don't spin that much because they're able to generate much torque from the wind. Yes. Now, so therefore they design the windmill with thick coils to utilize the pushing of the wind. They don't utilize how fast the blades turn. They utilize the but the unstable and faster winds, the more spinning you can take advantage of. So therefore they design the wind turbine with many tens of coils to gain much voltage rather than thicker coils. Because the faster you spin, the more advantage you can take out of the speed of the wind. Yeah, and the torque. The more the tens, the more lighter the weight of the blades must be. But the thicker the wire, the heavier the weight of the blades must be. Now what I'm saying is it's like I'm reading too much, so you will not really get what I'm saying. I'm trying to mean that if you realize the wind is now so quiet, it will start to blow very fast. After some time it gets quiet, blows fast, gets quiet, blows fast, gets quiet, blows fast. That kind of speed. Yeah. So I must be able to design a wind turbine or windmill that will have blades which its blades are very light in weight, such way it can spin very fast. And I take ones that we already know of or heard of. Yeah. And the coils must be thin, such way that I want to wire more. Because the more the thins, the more voltage I can get. And the thicker the wire, the less voltage I can get. So that's all about what I was saying. Yeah. So the final thing is when it's blowing very fast. So wider width of blades, very thin coils, such that I can wire more and get more voltage to feed into the inverter. Let me show you the inverter. Yeah, let me show you the inverter. I'll be feeding the what you'll be getting from the windmill into the controller, and then charges the batteries we do have. Okay, yeah, this is the inverter. This is the inverter. I'll be feeding that power into this. This is the controller. We're getting power from the rooftop, from solar panels, all the way to this side, into the controller, and then the controller charges the batteries here. Just thick batteries here. This one is more useless because it got spoiled before its time. And this is the inverter used to power the house. Right now we are running it, but for now we want to use another different option. Such a way that if the sun is not shining, we use the windmill to power the controller to charge the batteries. So that's it. Let me pause the video and let's start business. Okay. So now this is what I was talking about. The fan in the car that helps in the cooling system of the radiator. That's this system. It's made of thick coils. So I was able to dismantle it. That's what I got. Able to get this. Able to dismantle it. Yeah. You realize that the coils are very thick. The coils are very thick. coils are very, very, very thick. These are the magnets. I don't really need the magnets. These magnets, because I'll be using a different magnet. Magnets which are smaller, very small, but very, 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 very strong to handle. That I ordered for. They're not that expensive. This small but powerful magnet. People have done many videos about this powerful magnets we do have here. You can watch them in. You educate yourself. When you take this from the car, the fan system, you don't get this. I just ordered it. I was using to do some project where it failed, so I had to leave it like that for the meantime. So you get something like this. Now I have to take off these thick coils and wire a very thin one. So when I'm taking them off, I'll get something like this. That's the very last one I'm supposed to take off. It's very, very simple taking off. You cut one part off and just peel it off. I just use my plier. That's it. I cut one part off, then I take it off. You see, very, 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 very simple. Very simple. That's what I did. I took off all these, and I was able to get. So when you take them off, realize that you're able to get stuff like this. Get all these. Baby, I don't need all these for anything for now. Maybe I can use for a different project or different workout. Yeah. So put that one aside. I need thinner ones like this. Thin ones like this to wire. Such way I can wire more and get more voltage. Or generate more voltage rather than this. The normal one. There's a wide gap between them. This one is far thick. And it's far thin. The diameter of this is 32. The thicker the diameter, the smaller the thickness. I'm sure you know of that. Okay, yes. So the other part that as we move further, we will get to know is this side, the turbine. When you are mounting the blades, you mount the blades on this. So automatically, you don't use this part. That's where the brushes will be. If you're using brushes to wear out over some period, you must use that kind of new motors we are seeing in the system, the smart drive, whereby the magnets are the ones which move and where the coils are stationary, such a way that the brushes don't wear out over some period. You get me? Yes, so for this, we are changing this system from being using brush to not using brush, whereby the wires will be out this way and a whole container will be here with the magnets to turn, and the blades will be here. So as this one turns, that plastic thing containing magnets also turn around it and will be generating current. All this is stiff. Inside is stiff. Everything is stiff here. You get me? Yeah, so that's what actually we're doing. Now we already know that many people decide on how to configure this. Some may do it positive, negative. Some may do it positive, then negative. But I will prefer positive, negative. So after I'm done, I explain to you why it's positive, negative, and why I'm not using a different style or different way. Now I'm wiring my own this way. I'll be wiring my own for this. After that, I move to this. So each and every one, I wire it individually. Yeah, I wire it individually. But the main purpose that I want you guys to know, or the viewers to know, is this side. You not be using brushes. Brushes wear out for a period. And we want to bring down the windmill and put in new brushes. Waste of time and so we do it brushless with this wire. Scratches whereby to generate much heat. Now this pipe around the motor, this pipe is I asked the person told me it was 2.5 inches. Yeah, 2.5 inches. That's 2.5 inches. Yeah. So 2.5 inches will give you a very little allowance between the stator and the magnets. The magnets I drew them. I drew them. I drew them. I used that was a 40. I don't know why it is 40 millimeters. 40 millimeters diameter of the drill bit to drill it. I have to expand it a little bit so the magnets can drop in. The reason why I use the PPS is because some of the holes were bigger than the magnets, so I had to support them very well. You see how it is. What the magnets are in. And the magnets I've arranged it in. It's not positive negative that I said at first. I was using the wrong thing. It's rather south, north, south, north, south. So let's say this is north. The next one will be south. Then the following one will be north. Then the next one will be south. Following one will be north. The next one will be south. That way. So it's north, south, north, south. And the same thing is for each. So if this is north, that will be north. If this is south, that will be south. Because I don't have a straight long magnet which will represent north across, I do it two pieces of magnets, but they're not facing to the inside. So it's north which is facing to the inside, south of this which is facing to the inside, north of this facing to the inside, south of this facing to the inside. You get me? Yeah. Now, if I do it that way, the way I drew or the way I wired the configuration inside in the previous picture, this picture, the way I wired it will cause it to give a reverse current. Let me show you a little calculation or a little diagram of what I'm seeing. If let's see you really get what I'm saying. What I actually mean is that includes the wiring was done this way. For the first bar of the stator, then the second bar comes that way. What I've done here is 200 turns, because what I did in the work was 200 turns. This is 200 turns per bar. It's not small work. It took me almost 30 minutes in doing each bar. 200 turns. You keep pressing and pressing and pressing and pressing. 200. So if add all this, that's 2,000, because they're in series. Okay. Let me move. Continue. So each bar. So this is the first bar. That's 200 turns. Second bar 200 turns. They're all 200 turns. But I want you to get something about how I configured it, such that it will match the north south thing I was talking about. And I realized that when I place the magnets across these wires that I've drawn, if I place the magnets across these wires that I've drawn, realize that here's the north and the south is there. Here's the north and the south is into this laptop. There's the north and the south is there. So at this part is the north. So let's use the first one as the north. So that's the north. Because is the north side of the magnets which are facing. And the second side is the south which is facing. So here's the south is facing, the south is facing in the inside. So south is facing. Here the north is facing. That's the third side. So it keeps moving to the end. It's continuous. Now here's north, south, north. This is also 200 turns. All of them are 200. If north bar cuts across this, I'll have current flowing, let's say, in this direction. And if south or the south pole of the magnet cuts across this, I don't have current flowing in this direction. I have current flowing in that direction. You get me? Because north is this way. It cuts across, it goes that way. So if here was north, I would have also gone the same way. North gone the same way. because this is south, to go the reverse way. That will cause that reverse, and this will cancel out, not giving you any voltage or current. This is what the problem was. For the north here, the current will flow in this way. You get me? Yeah. So now I have to change this configuration by taking this off, and so in order for me to change it, to change this side, I have to change the configuration. That's this way. The other color will be that way. The other color will be that way. Even though here will be north, here will be south, here will be north. Same thing I've just drawn. I will just change this wire, because when south runs through this, I'll get my positive here, negative here. Then north, I'll get positive here, negative here. So I'll just change this. Again, put this negative. I'll connect this wire to that, and connect the wire of the south to this. It doesn't touch this wire. Then I'll fuse this symbol here. Connect to this, and the same thing I'll be doing to the end. Such a way that if current flows through this, it goes in that direction. Current also flows the right way, that direction, and flows. You get me? If I don't do it that way, I'll always be getting a reverse current at each north and south, and I'll not be getting any voltage. So that was the problem. That was the main problem. The reason why I don't want to use north, throughout, and leave the way it was supposed to be, like how this was, whereby I change this to north instead of south, try to just flow that way, because I want to get something which is sinusoidal. That's this. The north creates this rising current or voltage, and the south creates this. The north creates that, the south creates that, the north creates that, the south creates that. Because as the magnets move, north will come here, the south will come here, north will come here, that kind of movement. If you don't get what I'm saying, when you see this one, this part, this one here, immediately I turn the container, if it's not which was already facing, south will come. If south is facing and I turn it, whether clockwise or anti-clockwise, north rather come. So it goes north, south, north, south, north, south, north, south, north, south. That will give me something like this. So that if it was not that way, I would have been getting something different. I don't really know how it look like. Whether it will be like this or what, I don't know. Or it will be this way. Because it will only be north. This is no place, this is not DC, I beg you. I'm dealing with AC. I don't know what to give me, but you want something like this, a rise and a fall, rise and a fall, rise and a fall, sinusoidal value. Okay, let me do the testing to see what kind of voltage I'll be getting from the device I've created. Stop talking plenty. Yeah, that's the device, my meter, this down type that I'm using. Let me place it closer. Not the positive and negative. I'm just testing to see whether what I'm doing is right, instead of having the final stuff. Yeah, place it at 20 AC. That's the wire. Put it on. Meter is full, it's crazy. Okay, I'm turning it. It's a little. Like I'm not getting anything. Okay, we're connected. Okay, let me try it again. Yeah, 1.5, 3, 4. I've been getting 4 volts just from the normal spin. Maybe because it's scratching. It's scratching. It's not at the center. Just I'm able to turn it easily. It's scratching. So I have to go and balance it today. Just imagine if it was able to spin very fast, the amount of voltage I was able to generate. Because just from normal movement, I think 1.5 volts is, yeah. So that's that testing. Can you test the current? Then put it to 200 milliamps. 200 milliamps and see what I would be getting. No, no, did a mistake. This terminal is not supposed to be there. It's supposed to be here. I'm very careful that no wire goes in. Let's to scratch. Okay, let me try. What's wrong? Okay, sorry, this one, sorry. That's the current amount of current I'm making. The scratch, I don't like the scratching. That's the amps I'm getting. And the voltage was somewhere 4 point something. The amps is around 63 point something. Under 200 milliamps. Not 20, 200 milliamps. So for this, I'm expecting high voltage. Because everything is in series. Everything is in series. Everything is in series. Okay. So that's the amps I'm making. That's the arms I'm making. That's the arms I'm making. Let me show you the drilling bit. That's the 4.01 I was talking about. This one. I used to drill the hole. Just dangle it with the drilling machine. And I was very careful to hands. If you may get it. I don't forgot the reason why I used the metal. I was from the start. It was plastic that I was thinking of. Something of this sort. Just a cup, normal cup with drink in. And I broke into two and melted. But I got bent, I bent my fingers. So I was very serious. I tried it almost 5 times. I realized nah, it's best I go for the metal because it won't help. Just hit myself. So for this, I didn't realize that it was even cracking. I wanted this such way that the magnets can act independently instead of this, whereby it's some slight magnetism between each magnet. Yes, I'm outside for more light. This is what I did. That's for the plastic one. For the plastic one, I took a mosquito spray container, emptied it. I was very careful of that. Placed it on fire. Cut pieces of these caps and melt it. I realized that there's a kind of tea roll, toilet roll container inside. That gives me the circular shape that I'm looking for to match the state of the motor. State of the motor. It's nothing difficult. And if you look at the motor very carefully, there's some holes that I drilled from the start. I told you about what those holes will be functioning as. That will be holding the propellers. So these are the screws I'll be using. These are the screws. Another screws will be placed inside. That gives me the set. And the propellers will be screwed that way. I'll show you links to other people's videos. I'm sure to be below the video. Links to other people's videos on how to design the propellers and how to use them. They cut almost half of it. When you use it, cut half of this end. Come on, half of this end. So they cut here off, and they use this side. You just screw that way. The other side is screw. The same way throughout. Yeah. The bit that I used was 40. I forgot to say about that. I nearly broke it. After drilling, I try and dangle the device or the bit with the machine to create the hole bigger for the screws and not to the bolt and not to enter. Yeah, the first propeller I did, that's this one here. The first propeller I did, this around 40 in length, two at this end, one at that end. So it's in inches. I'm dealing with inches. I'm dealing with so 40 to 1, 40 to 1. Always take note. 40. So yeah, I'm correct. 40 inches, 40 inches, 40 inches. So that's the people I used for the cutting. The pipe is in there. Forgot to even bring the pipe. So 40 inches, two at that end, one at this end. But after I was done, I realized this one was bending. It was bending. I don't want it to bend. The wind is blowing. If this was bending, it can't cause the motor to run. And then design another one. That's this. This one is 44 2. 44 2. It's of the same length, but of different ends. It's of the same length, but of different ends. The length is 40 as all of them. Here is 4, and that side is 2. Again, 2. This will be the best. Doesn't dance like the other one. It's stronger. Then when you lose it, it will be better. Whoa! So to be fitted this way, because this side is too big, top end is too big, I must cut it as I said before. So that's how the propellers will be fitted, and that's it. There's nothing else more to talk about. The propellers are fitted. You just mount it the way you want to mount, and you generate your power. There's some stuff maybe I see in the video, maybe they are wrong. You want to correct them, feel free to correct them in the comment section below. I'm not interested in getting more likes or subscribing to my channel. No, I'm just interested in sharing an idea that I have, and that's it. That's why I'm also linking to other people's videos so I also get educated. So it's not for personal interest, it's just for that kind of education. Yes. So that's it. That's it. Continue. That's it. Be careful when this thing's on fire. Very dangerous. Must regulate it and regulate to as everything burn down. That's it. Boot everything. That's it. So I'm done. I'm done. Bye. Okay, yeah, I brought a pipe. The pipe itself. That's the pipe. That's the pipe. The pipe which I cut those slides out. I don't really know the diameter. I just saw it outside. Then I said, let me use it and see whether I can do something useful out of it. Yeah, that's it. There's nothing on it to show. Nothing on it to show. It's a PVC pipe. Nothing on it to show the inches. Okay. That's it. Okay. So I'm able to do it. That's so that and that's the final look. That's the final look. Those are the washers. Those are the coils inside. The magnets. Then the blades. Because I was not having much washes. That was what a ball bearing. I was not having much washes. That's why I did it. One, then the second one, no washer. My blades, I did not cut them all. So you realize that some is quite is quite turned than the other. Try and do yours the better way. Try and do yours the better way. Yeah, so that's it. Those are the blades. Anything's giving me that kind of free energy. If you want to test the power that can make from generate from this, no problem. In my meter, can do some small testing. So that's it. That's the meter. Let me just turn it a little bit and see what I'll be getting. Now I'm getting my voltage. It's because I can't mount it now. That's why I'm getting my voltage just from the normal spin. Getting some voltage. That's the voltage I'm getting. Because I not balance it, so it's spinning backwards. The reason why I pass the cable through the middle washer is because I don't want the cable to turn with the container. Yeah, I don't want the cable to turn with the container. Yeah, so that's it. That's it. Voltage. I'm getting my voltage from the spin, normal spin. The wind is now spinning. Still spin. Still friction. Yeah. Close to spin. Yeah. So that's it. That's the windmill. You mount it with the ball bearings below. So you can able to turn in the